documentation for our project Linux Software Packaging with App Image for Kennesaw State University, IT 4983, by Blair Hill, Robert Ryan, Dylan Parker, BISHWO MARHATTA, and SAMMI FIGUEROA. Project goals. Our main goals for the project per our project plan were to research app image software packaging and new methods for automated packaging, develop a working script to produce app images from software, have completed the final testing on the automated script and ensure the app images created can run on multiple Linux distributions, and ensure all documentation is in place for new users to start with a quick understanding of how app images are produced, common packaging information, and methods to look at for creating bash scripts. Our team was able to complete these goals and created an automated script that works as well as documentation to explain the process of how it works and how to use it. Knowledge and skills. Over the course of the project, our team gained a wealth of knowledge and skills. As the project was based in Linux distributions, knowledge of the Linux OS was a requirement from the very beginning. Our team knew very little about app image and how to use it. Researching skills were necessary to be able to fully understand what was required of us. Therefore, we as a group and individuals needed to be able to research topics properly and efficiently. Since automating app images was one of the main goals for the project, being able to create a bash script was an absolute must for the project to be completed. For our documentation, we needed to understand how to create instructional guides and document our steps taken throughout the project. For doing this, we are able to provide Novice users and future Capstone students continuing this project to understand how the bash script works and what our process entailed. Lastly, app image was selected by previous groups to be the best solution for packaging software. As mentioned before, our team knew very little about app image. For research, we were able to grasp an understanding of app image and its many tools. Project management. Over the course of the project, our team held weekly meetings with Dr. Sang to help keep him informed of what we were working on, as well as to discuss any questions we may have had. The team communicated throughout each week for the apps, Microsoft Teams, and GroupMe to keep everyone on the same page. We made use of a Gantt chart to keep track of deadlines and deliverables, and the team also used weekly logs to keep track of team member contributions and team meeting attendance. Resources. Before we look at our milestones, here's a quick preview of some of the tools, platforms, and software we used for our project. Now I'll pass it to Dylan to speak more about milestone 1.
Thank you, Sammy. So as we began milestone 1, our first and most important goal was to research how the app image format works, the requirements needed to actually make one, and how they were actually created. Once we understood the details, we wanted to gather a few relevant pieces of software from our project sponsor, Dr. Sang, and manually package them into an app image. From there, our goal was to begin working on a solution that would be able to create app images automatically. As we began our research, we found that app images are created from a special directory called an appdir. An appdir needs to have specific files in a specific structure to properly package into an app image. Here we can see an example appdir, which contains an app run script that acts as an entry point to launch the program, a desktop file entry that holds metadata about the application, an icon image with the PNG extension, a user/bin directory that holds executable binaries, a user/lib directory that holds required libraries that are not expected to be present on the system, and a user/share directory that holds resources used across multiple binaries. So AppImageTool is the fundamental utility used to package appdirs into app images. This program is provided by the creators of AppImage and can be found on GitHub. It works by compressing the appdir into a squashfs file system, which is treated independently from the host machine's file system. Then it embeds that file system and an execution runtime into one file to create an app image. When a user opens the app image, The runtime mounts the file system as a read-only image in a temporary location, and then it executes the app run script to launch the specified application. So once we understood how AppImage works, how to create them, we were able to successfully manually package our first piece of software. And so here you can see we have CView running as an app image on Ubuntu 20.04. During our research, we found a higher level tool used to create app images called App Image Builder. We chose to try and create an automation solution with this tool specifically because it provided a lot of functionality out of the box, like automatically creating an appter, using APT Package Manager to automatically download software, and automatically using App Image Tool to package it into an app image. The way App Image Builder works is by taking a YAML file as input, which is essentially a recipe that tells App Image Builder what software to pull, where to get it from, and how to package it. With our bash script that used App Image Builder's functions, we were able to package more than a handful of programs. These are a few of those programs we were able to package. And while we mostly focused on packaging tools specifically geared towards bioinformatics research, we occasionally included other pieces of software like Inload or Gnote to spot check our solution's scope with. Unfortunately, this was not a perfect solution and it had a few glaring issues. We ran into a technical issue due to how APT Package Manager works. When the package manager installs a piece of software, it asks where it should be installed. And there's a wide variety of possibilities for this location, but we needed to know it beforehand in order to properly create that YAML recipe file. We were unable to find a way to get this information, so the script was able to work most of the time by using the most common location of user/bin. Taking a step back, Dr. Sang pointed out that we had a reliance on the APT package management system as a whole. Since App Image Builder relies on APT, we only had access to software included in the Ubuntu repositories. And sometimes those repositories don't have the desired program or might only have old and outdated versions. We were also relying on a third-party tool, which might be unsustainable in the long term. It's entirely possible that App Image Builder might become unmaintained in the future since it's not an official app image project. And now I'll turn it over to Robert to talk about milestone 2.
Sure, thank you, Dylan. Good evening, this is Robert Ryan. I'll discuss our contributions in milestone 2. With the issues from milestone 1 in mind, it was clear to us that as we move through milestone 2, we would need to go back to square one and do some research. Our project sponsor, Dr. Sang, suggested that we reach out to the creators of AppImage since they would be the authoritative source on information in our situation. They gave us some better insight into how we could better package software in our project. Some of the areas that we needed to investigate were: how could we find dependencies for any arbitrary piece of software, like something potentially downloaded from GitHub, or usually newer software that isn't currently released and put into the package manager on multiple distributions of Linux? How could we use the command line to download software from online resources such as GitHub or other project websites or specific developers' websites? And how could we embed special runtime dependencies like the Java virtual machine for Java-based programs, or even specific versions of Python? So going forward, we actually did get a response from the creators of AppImage, who are the exact people who made the packaging solution we're testing. So these are the exact people, that would give us all of the information we needed for our project. So initially we reached out to Simon Peter, and he was the creator of AppImage, to see if we could get any insight into our problems. And we wanted to double check and make sure that we didn't miss anything in our research into the exact path issues that we had from our last solution. And he did confirm that there was no hard rule for how to package software in Linux. We also asked him about finding dependencies for new software that could be that were downloaded from GitHub or any developer website. He explained that app image and Linux deploy third-party tools they leverage third-party tools for making app images, such as the LDD Linux command internally. So we followed up about the LDD command, and throughout the project, we continuously tried to research some of the different Linux tools that we could leverage to try to find those system dependencies. And we were curious if a program needed to be installed for it to work. And he let us know that the program did need to be installed, or at least configured to be executable to leverage that utility. So once we got that out of the way, we dug a little deeper and we tried to find dependencies, and we found that the program dependencies could leverage that LDD command. And his tip, Simon, the creator of AppImage, he noted that it's just a general command that uses the standard dynamic linker. And what that really means is it looks for programs and checks their shared libraries that they need at runtime. And this is extremely useful because most Linux programs use these shared libraries by convention. And what we later found out is that LDD works by reading the dependency listed for an ELF file. And what ELF is an executable linkable format. And essentially what it does is it's a executable binary, but it has extra metadata. And what all the metadata specifically shows about that program is all of the structures, the libraries, and all of its core files that compose it. And later, we found out this format had been a standard for Unix platforms, including Linux, since the 90s. So it's been around for a while. Almost all developers are familiar and are using this today, but we needed to dig a little deeper on how we can actually leverage it. And in our experience after our final testing, every executable that didn't need an interpreter like Java or Python actually used that ELF format. So further, our next step in our milestone 2 research and development was pulling software from the command line. So some of the tools that we were using were the git clone command, curl command, and wget. Git clone is used with the Git version control system used by many remote repository services such as GitHub and GitLab. It allows the user to copy an entire content of a remote Git repository. And then the next tool was curl. It's a command line utility that's mostly standard on Linux and Unix systems, but sometimes you do need to install it from the package manager. And what it does is it allows you to pull from multiple different protocols from things from the internet, such as HTTP, FTP, SMTP, and even more than that, secure and unsecure. And what it does is it allows you to download files after pointing it to a URL. But we found it was limited in our development because it wouldn't download files recursively. So if we wanted to pull down a whole directory, we couldn't use that tool unless it was only one executable. So that led us to the other tool, the last tool, which is wget. And it's a more simplistic and straightforward tool, and it can download files with the same protocols and then some, and it could download those files recursively, so for a directory. So essentially what you do is you use the wget command and you pass a link, and it will automatically build and send the appropriate request to pull down the whole repository recursively. So for our case, git clone and wget proved to be the most straightforward and usable tools to accomplish the tasks for our bash shell scripts. So here, lastly, was when we started working with Java and other runtime dependencies. So packaging Java applications is a little bit different than regular app images. Since Java class files aren't ELF files, the Java program and its dependencies need to be included in a Java archive or .jar, and that's typically in the /user/bin directory. A Java virtual machine also needs to be included in /bin or /user/bin directory to run the jar file. And because of this special case, the entry point of the program, it really isn't the program itself, but it's a script that calls the JVM to run the jar. So in the end, this still produces an app image that functions like all the other app images we packaged. It just took a little more time to develop, and you have to be aware that that is a requirement. So I'm going to pass it over to BISHWO, and he's going to continue talking about milestone 3.
With our research from milestone 2 in hand, we moved on to milestone 3 with a few new goals. We set out to create a new automation solution that leveraged the research done in milestone 2 to address the issue faced in milestone 1. We also knew that documentation would be an important aspect of this project for future groups continuing this research. So we made sure to create a detailed write-ups of our app image research, as well as how to properly install and use automation scripts. The main goal with our new script was to eliminate the need for third-party tools. We did this by creating the code, the app directory creations ourselves, dynamically creating desktop entries, and including a comprehensive app run script that counted for either terminal or GUI-based applications. The most important last step is that it uses IDDs to find the dynamically linked libraries needed at runtime. It copies the libraries into the app directory and calls app image tools to package it into an app image. While the script does automatically create the app image, the software still needs to be downloaded manually for now. Using our new script, we were able to make app images from any piece of software that was downloaded and properly configured to run on the system. Two of the most notable programs we were able to package with the solution that we couldn't with our first solution was Mothor and Kraken 2, seen here. This solution was a step forward because it continued to cover the domain of our first solution, since it could package software configured by the APT package manager. In order to ensure the app images we created were portable, we tested them across traditional segments distributions of Linux. Ubuntu is popular distribution with many users, including our project sponsor, Dr. Singh, so it was used as the main development platform. Arch Linux is a minimal distribution with a bare minimum of libraries included with systems when installed. Our testing confirmed that app images made with our script ran on all 3 distributions. From the progress we made during the semester and the insight from our sponsor, Dr. Singh, we knew it was likely another Capstone group would continue working on this project in the future. We knew it would be important for these future researchers to get up to speed quickly. So we compiled our understanding of app images format into a research document. We made sure to detail each part of the app directory, how app image works, and the quirks we found along the way. We also detailed our research and thought processes on using App Image Builder and explained the pitfalls with that solution. We have laid out our research about finding dependencies and what tools are useful for downloading software from the command line. And of course, there are detailed comments throughout both bash scripts explaining their functionality as well as installation guides and how to use them effectively. Now I'm going to pass the mic over to Mrs. Blair.
Thank you, BISHWO. Our consensus is that the project experience was a great one. As individuals, we were able to learn a lot about Linux and App Image. And as a group, we were able to contribute to a research effort that is bigger than any one person. We feel this project has improved our teamwork and communication skills, which we will certainly translate into real-world applications. Producing a solution to an open-ended, real-world problem was difficult but rewarding. It took large amounts of research, critical thinking, and collaboration to achieve our goals. In the end, we're appreciative of this opportunity to push our limits and find out what we're capable of. With each milestone passed and achievement made, we ran into a new set of challenges. Our first challenge was to understand the app image format and all the necessary parts to make one. Being a mostly community-driven project, the documentation is not always easy to understand and is spread across many different pages across many different websites. This made it difficult when we initially started trying to manually package software. App image tools seemed to constantly throw errors because we didn't have something in the correct folder or we had a formatting issue. Once we did get the hang of manually packaging software, our next major challenge was automating the process. Creating a bash script with this kind of functionality required knowledge of app image tools and Linux system calls that none of our team members had. It took a lot of research to find the few useful commands out of the hundreds available and how to use them properly. It was also difficult coming to terms with the fact that we needed to circle back to square one. Our first solution had limitations that we couldn't find fixes for, and we simply needed a better plan. Unfortunately, this also led to a bit of a race against the clock towards the end of our project. We were able to make a better solution that automatically created app images, but we weren't able to add the functionality that uses git clone and wget that we wanted to. Fortunately, we feel that we are leaving this project in a very natural place for future Capstone groups to pick up where we left off. We have created detailed and consolidated documentation on the inner workings of app image so that future groups can get up to speed quickly without having to run all over the internet like we did. We also demonstrated the limitations of using third-party tools like App Image Builder so that future groups don't have to waste their time and energy exploring that possibility. Our second script solution is also in a great state. It automatically creates app images, and with the research we did about command line tools like git clone and wget, future groups should have a good foundation for extending the script compatibilities to downloading and installing software before packaging it. In conclusion, we think AppImage is an interesting and useful format. It's a free and open source project that helps make software portable across Linux distributions. This has benefits beyond just packaging bioinformatics software. Making a centralized repository of research tools as app images that work on any distribution could streamline academic research across the country. And automating app image creation is just one step towards those type of possibilities. Along our journey, we found some approaches that didn't quite work, but we ended up with a promising solution that future Capstone researchers should be able to take to the next level. We hope the work we've done will help the Capstone program and the research community as a whole. Thank you for your time.